person's located at the edge, another person's 3/5 r, and another person is half r from the center.
And what are they asking about?
Um, they're asking about the period of rotation, the velocity, and the acceleration for the second and third person.
Okay. So I hate to do this to you, but can you tell me about those three people again?
One of them is almost standing on the edge. The second one is 3/5 r from the center, and the third is 1/2 r from the center.
All right. This is the 1/2 R person. This is a 3/5 R person, and this is R. Now, if the platform is rotating, they all have the same angular speed. That's the first thing. They all have the same angular speed, which means they all have the same period. They're taking the same amount of time to go around the circle. So I don't know what information has been given besides this, but they all are going to have the same period and the same angular speed because they're all on the same platform. The only thing that's different is that their distance away gives them different velocities. The farther they are from the center, the faster they're going because velocity equals omega times r. So the guy on the edge, he's traveling fastest. The guy half r is traveling half that speed. Since it's a linear function, so the guy on the edge is this one. This is the edge guy. The guy at 3/5, his speed is going to be omega times 3/5 r. And the guy at half is going to be omega times 1/2 r. But they all have the same period, and they all have the same omega, all the same angular speed. Roxy, is that enough? Spoken into the netherworld. All right, excellent. Is there any other questions on the homework you'd like to ask? Ryland says number 9. I don't know what number 9 says, but I'm happy to do number 9.
Number 9 is the one, it's determine the distance above Earth's surface to a satellite that completes, for me, it's at least 2 orbits per day.
All right, so we did talk about it. I'll work through parts of it. I don't want to do all the numbers. So I'm going to go right back to what we kind of had written out a few minutes ago, in that we have MEGT squared equals 4 pi squared r cubed. Now, you could derive this from our principles, but I already did that once. Actually, I've done it 3 times today, so I figure out I'm good, right? I can just write this down again since it's like 3 slides back. We're looking for this kind of, not really, but we need that number in order to get the altitude. We were told t equals 2 orbits per day, so that's 12 hours for an orbit. We can't leave it like that, so we need to convert it to seconds. So there's 3,600 seconds in 1 hour. So you'll need to get that in seconds. Aside from that, once you get this value and put it in here, all you're doing is solving for this value for r. But again, I need to point out that's not the answer. Because wherever that satellite has to be, what you're finding for r is this distance. But they actually want the altitude, which is this distance. So you need to adjust by, subtracting this radius of the Earth, which is 6.3 7 times 10 to the 6 meters, I think. You might need to look that up. Yeah, you might need to look that up. I think that's it. We might need to look that up. Is that enough to get you to the end there, Rylan?
So then for number 8, we just use the same because if we don't have enough information for any of those planetary questions, we just use the information they gave us before.
Well, I think you have access to the internet. And there's also a table of all the planet stuff in your book, and that's what they're counting on you using.
Okay.
So I mean, if they're asking you to calculate a period, no, I don't want you to look up the period. But if they're asking you to calculate the orbit of one of Galileo's moons around Jupiter, I expect you to look up the mass of Jupiter. Yeah.
Thank you.
You're welcome. Now, on a test, I will not be having you look stuff up. I will give you those kind of things. But this is homework. So, yeah, I expect you to figure that, to go and look for that kind of stuff. All right, last chance. Anything else on the homework?
Can you please go over number 3, which is the roller coaster loop to loop?
Yeah, I'd be happy to. You'll have to give me some of the information in it, though. I assume you're looking it up, right?
Yes. So it says express. Compare the normal force that the seed exerts on you to the force that the Earth exerts on you when you are passing the bottom of the loop.
And is there information about this loop?
No, it's just variables.
This is Adam, right?
Yep.
You said this is number 3?
Yep.
All right. So it says determine the direction of the acceleration at the bottom of the loop and construct a force diagram for this position and compare. So there's more to the problem than what you actually just said. I just need to see what the context was. So, all right. So first, we're going to have to assume that you have some velocity down here at the bottom. That has to be true. But no matter where you are in this loop to loop, you could be anywhere in this loop to loop. And I want to be clear, I don't have to always ask about one of these spaces. I can ask about any space, and I expect that you can construct a force diagram. So let's consider all of these different places that we could be in. Okay. The first thing you have to understand is that no matter where you are, the net force has to be this way, towards the center. No matter where you are, the net force has to be this way. There can be other forces, but the net force has to be that way. There has to be a component of the acceleration towards the center, or you can't travel in a circular path. Now, for all of those places, that's going to have to be the normal force. It's the only thing exerting a force on the cars besides gravity. So at the bottom, the normal force has to be greater than the weight. It has to be. There's only 2 forces acting on the car, and the unbalanced force has to be towards the center. So there needs to be a condition here where the normal force will have to be greater than weight. You feel heavier at the bottom of a loop. At the top, it's different. There may not even be a normal force acting down. But if there is, it's probably going to be relatively small. Now, it could be bigger if it's going really fast, but both of these forces are downwards. There has to be enough force downwards to ensure that you travel in the circular path. Now on the side, it's a little wonky because in the side parts of the problem, there's sure to be a normal force, but there's also going to be your weight acting downwards. Now, these are a little weird because there has to be a component of the force towards the center that's causing you to turn. But there's also a component of the force downwards that's causing you to speed up. We don't talk about those in this class very much because we tend to focus on the parts of the problem where you're at a constant velocity, where the normal forces and the weight line up. But there's no reason why you can't consider that over here, there's got to be a normal force towards the center and the weight's acting down. What's happening here? Well, the normal force is pushing you to the side so you don't go straight upwards, and the weight's slowing you down because you get slower as you get to the top of that loop. So I expect that you can draw these free body diagrams like this, but I do expect that at the top and the bottom, you can make comparisons between the normal force and the weight. In fact, I'll expect more than that. I'll expect that if I talk to you about the velocities, you can tell me how fast they're going, how much normal force there is. In fact, I will also ask you questions like, what is the minimum speed that you have to be going to make it through the top of the loop? And a question we did in class. Those are all things that I would kind of expect you to be able to discuss and talk about with these questions. All right, Adam?
Yep, thank you.
You're welcome. Well, folks, it is the end of our class period. And I got to tell you, I'm really appreciative that you guys are all here. I will definitely make sure that it gets reflected in your grade. I appreciate your hard work. Please make sure the homework is done. We will have a quiz probably Monday or Tuesday on this. The only reason I wouldn't have a quiz on Monday is because it's hard after 2 days of nobody being at school to jump in on Monday and do a quiz. But that doesn't mean we're going to stop. Our goal here has to be to finish where we want to finish by Friday so we can have a test Friday and walk away to the holidays. We are having a test next Friday, rain or shine. Well, hopefully it doesn't really matter if it's raining, but you guys get the point. All right. All right, guys, have a wonderful weekend. Thank you very much for being here today. I do appreciate it. And I know that it's not what a lot of your other teachers are doing, but I really don't care. I'm glad you guys are hard workers. So have a great day today. It does look like it's beautiful outside. So if this is your last class, please go outside and enjoy it. On the other hand, if you have a bunch of other classes, bummer, you'll be stuck in Zoom hell for the rest of the day. So talk to you all later. Have a great day and do something fun this weekend, but not too fun. I don't want you quarantined again. So don't have that much fun, or have fun, but wear a mask. That would be nice. Yeah. Don't bring your COVID
Have a
to
good
my
weekend,
school.
Mr. Shelton. Thanks for actually
You
hosting
too.
a class.
No worries. I love having Zoom
Bye,
class.
Mr. Shelton.
Bye-bye, guys. Alexa, order more detergent.